All right, so we are here in this beautiful pre-calculus class on December 6th. Let's go ahead and write that down. We are in December 6th. And we're talking about direction of vectors today. So I could always say direction of vectors, and every single title could be of vectors, but we know we're in Unit 3. Unit 3 is all about vectors. So let's talk about the conceptual understanding here. So let's assume that we have this vector. This vector has its initial point at 0, 0, the origin, and its terminal point is 8, 5. So it has this length here. I mean, I could ask you a bunch of questions about this because we know how to find the magnitude. Another word for magnitude is length. Yeah, there it is. So I could ask you a bunch of questions, but the question I'm asking you now is, what is the angle? The angle that I'm asking for is the angle that you make with the x-axis. So this angle right here, you can draw that on yours as well. What is this angle? And usually with angle, we use this theta. And again, if you don't know theta, it is up there. It's one of the Greek letters that you should know, especially if you're talking about maybe joining a sorority or a fraternity, whatever you're doing. So in college, if you join a sorority with all girls or a fraternity that's both co-ed, so both males and females, Greek letters, usually 3 Greek letters define a fraternity or sorority. So just memorize those and you'll be like, oh yeah, have you been to AFIU? And it's like, what are those? And it's like, oh, you have to memorize those letters because that's how you get into sorority, or you don't have to get into sororities, but you should be able to identify them. If you see them up on the house, you're like, oh yeah, that's AFIO right there. And I was part of AFIO also. So anyway, general formula. We need to somehow derive a formula, and that's what I want to do here. So whenever we have this diagonal length, usually we can make a triangle, right? A right triangle, it would be nice too. So I'm going to make my right triangle. Let's go ahead and make that with Mr. Sindel. I'm going to use my line tool to make a line that goes down here. And of course I have that x-axis as well, so there's my other line. And that does make a right triangle, and that's the whole point, because with a right triangle, I have right triangle trigonometry. There's a whole other branch of trigonometry, by the way, that's dedicated to non-right triangles. That's where rule of sines and rule of cosines and all of that stuff comes from. But we're dealing with a right triangle, nice and easy review stuff. So katoa. One of those 3 things, sine, cosine, or tangent, is going to help us find this angle. Do you kind of agree with me that sometimes it's a little bit hard to find the magnitude of a vector? Sometimes it's like square root of like 39 or something like that. Sometimes it's hard, right? We nod our heads. So let's not use the hypotenuse. That's hard. So you can say, don't use the hypotenuse. No. X, or you can just leave it blank. But we do always have these really nice side lengths. How long is this leg of the triangle right now? It goes up to a height of 5, so that has a length of 5. And then the other longer leg has a length of, yeah, you can say it louder, you got it. Yeah. So we know that this is a triangle with length 5 and 8. Is there some form of trig rule that uses both this leg and this leg? Is it sine, cosine, or tangent? SOHCAHTOA. Which one of those is it? Which trig rule uses 2 legs, no hypotenuse? Do you remember SOHCAHTOA? Here, let's write it out, just in case we forgot. Capital S, O over H, C, A over H, TOA, T, O over A, TOA. All right, so if this is my angle of reference down here, I know that this is going to be my H, my hypotenuse. Adjacent, is that the 8 or the 5? Which one is the adjacent? Take a guess, 50-50 shot. Rochelle, which one is adjacent, 8 or the 5? It is 8, because adjacent means right next to my adjacent neighbor to me. So it's like your next door neighbor. Adjacent, what's right next to your theta? Well, 5 is way far away. It's on the opposite side, which is where opposite comes from. So that's our O. So I need to figure out which of these 3 letters, S, C, or T, to use, where I always use the 5 and the 8. I don't want to use the H. If they have an H, don't worry about it. Which one am I going to use then? Tangent, yep. So I'm going to be using tangent. Let's set up our rule. So write this out with me. So tan of our theta, tan of our angle, the tangent, is equal to what fraction? Is it 5 over 8 or 8 over 5? It is 5 over 8. And notice here, and this is a note that I want you to make as well, that the 5 happened to be the do you like calling it the height or the y variable? What would be better for our notes? How can you always say this is the height or the y variable or something that reminds you that it's going up and down. Or I can just say up and down. What would be easiest to remember that's always this height y up and down? What would you like to write in your notes? These are your notes. What will help you? Y, okay. You can say y or y-axis, and then that means that the 8 is the x. Okay, well now to find theta, do you know how to undo a tangent? This is a review from Unit 1 a while ago. Tan inverse, yeah. And the way that you do that is you take the inverse tan, so it looks like this. Arctan, like that, tan to the negative 1 of this 5/8. And when I do the inverse tan on the left-hand side, the inverse tan and tangent cancel each other out, and you're just left with theta. So this angle here is arctangent, or inverse tangent, whatever you want to say, arctangent of 5/8. So we can have our generalized formula. The generalized formula will always have arctangent. It'll always have that inverse tangent. I'm going to write this in red because it's important. It'll always have arctangent, tan to the negative 1 of, and you both decided we're going to use y and x, so we're going to say y over x. I could have written height over width or something like that, but arctangent of y over x. That is our formula that we're using for the rest of today. You have found it yourself, well, with me, but that's what we're always doing. So the other thing that you have to do is to always check what quadrant you're in. So if I'm in the first quadrant, and again, if you forgot the quadrants, here they are really quickly. Quadrant 1, 2, 3, and 4. If I'm in the first quadrant, x values and y values, are they positive, negative, what are they? If I'm in the first quadrant. If I'm in the first quadrant, x and y values are positive, exactly. So if I get, so say for example, I have an angle that's clearly down here in the third quadrant, and your angle you get to be 15. That doesn't make sense. 15 is right here. It's in the first quadrant, but it should be in the third quadrant. If ever your answer doesn't make sense, just add 180, bueno, then you're good. So always check what quadrant you should be in. And then as our note on top of that, our note of a note, maybe add 180 degrees. Sometimes you'll have to add 180 degrees. If you're in the wrong quadrant, you'll probably add 180 degrees. Otherwise, you're probably in the right quadrant. And we'll see an example of this, so don't fret about it now. In fact, I made the first example using this rule so we can see what happened. All right, so far so good? All right, let's go to our first example. So I have this vector. This vector is going negative 9i, negative 3j. So I is the x direction, j is the y direction. It's just how do you do it in vector notation. I want to find the direction of this vector, and I'm going to round to the nearest hundredth. Hundredth, by the way, is 2 decimal places. So if you don't like the word hundredths, that's the same thing as 2 decimals. All right, so what am I going to do? We have our formula. Let's use our formula. You can even rewrite the formula or fill it in immediately. I don't know what you want to do. So I know my theta is going to be equal to arctan of what? Arctan of what over what? Negative 3 over negative 9. I agree. It's the y component over the x component. When that's the same thing as 3 over 9, or 1 over 3, if I reduce it all, because a negative divided by negative is a positive. But I don't need to do that. Every single question that you're going to have today, you need a calculator for. Do you have one on your phone that you're comfortable with, or do you want to borrow one of Mr. Sindel's? I'll give you both a calculator, and you can decide to use it or not.
This is how you would such like a
No, let's not say that. Okay, so let's go ahead and do this on our calculator. I'll just use the calculator that comes with my laptop. So I have to do the arctan. So when I do that second tan, I do that after I do the value. So I'm going to do, let's see, clear this. So I have negative 3 divided by negative 9, and that's 1/3. So you get 0.3 repeating. You're following along on your calculators, right? or whatever you're using for your calculation device. This is to practice for the homework. So you're following along. Get -3 divided by -9, which is the same thing as 1 divided by 3. I have positive 0.333 repeating on my calculator. Do you see the same thing? There should be a little plus or minus sign somewhere on your calculators. Let me pull one out so I can audibly explain. I think on the very bottom right, to the right of the decimal, there's that little negative.
Oh, right here. You don't have it. Sorry, but it's faded. It's down here.
The calculators are so worn out you can't see what the keys are saying. -3, yep. You see it, Rochelle? You got it? All right, so we have 0.33 repeating. We need to take the arc tangent of that. So you're going to hit second in the top left of your calculator, second, and then arc tangent. So hit second tan to the -1. And then you hit answer. So you do second and then that negative sign. Tan -1 of your answer. So second and then the negative to do arc tangent of the answer. Do you see it? And then hit equals, and you should get. Perfect. Okay, so let's write that down. This is okay, so we're doing an approximation now. Whenever you do an approximation, it's no longer strictly equal to. We do our little wavy equal to. This means approximately. So it's approximately equal to 18.43. 18.43. Notice that I rounded to 2 decimal places, 18.43. If this was a 5, I would round to 4.4. If this is less than 5, like a 4 here, then it's 0.43. So 18.43 degrees. Now, we just did that first star. We always need to do the second star. Okay, well, what quadrant were we in? -9, -3. What quadrant is that? That's the third quadrant, I agree. Is 18 degrees in the third quadrant? No. So that means we need to add 180. So, and you can write that in the notes. Should be in quadrant 3. You can circle it. So add 180 degrees. So I say 18.43 plus 180. And you can do that on your calculator if you don't feel confident with your mathematical abilities, but you should be able to do that in your head because it's just 198, then that 0.43. So this is equal to 198.43 degrees. Now that's in the third quadrant because it's a little bit more than 180 degrees, which is, in the third quadrant. So that is our final answer. Go ahead and box it. Unfortunately, the calculator is not smart enough to detect whether or not you should be in quadrant 3 or 4. It'll always dump you in quadrant 1. I think it'll always dump you in quadrant 1 and 2 regardless. So if you need to be in quadrant 3 or 4, you probably have to add 180 degrees. There's a hard, fast rule for that, but I just like you girls, to be using your logic.
It would have shown it to us if you had a 2018 calculator.
Probably. The newer calculators might be smart enough. Eder Hood. All right, so we are on to example number 2. You two are helping me out. What am I doing? Tell me what to write. Theta
Equals tangent
inverse
5 over -2.
5 over -2. Okay, and then let's do that on our calculators. So I do clear this, 5 divided by -2, and I get -2.5, and then I take the arctangent of that, boom, and I get that answer. Oh, so it'll always dump you in quadrant 1 and 4, because this just dumped you in quadrant 4, right? All right, so we write that down, -68.20, approximately equal to -68.20, rounding correctly, because this 9 needs to be rounded up because of an 8, so if it rounds up, it carries over to the 10th place, so it's 0.20. All right, and finally, what do I do? Bless you. Salud. What do I do next? I have to do that second star, right? Okay, well, what quadrant was this vector in? But this dumped us into 4. So we need to, Daisy?
Add 180.
Yeah, we need to add 180. So this should be, we can say, this is in quadrant 2, but this is in quadrant 4. So that means we need to add 180. So plus 180. And that's going to be 4 there. So 2. Wait, not 2. It's going to be, oh, we're doing a subtraction problem. Maybe I want to write it like this. Oh, we have calculators. I'm lazy. I'm just going to add 180 on my calculator. And I get 111.80. Is that what we both get as well? So plus 180. What am I doing? I need to write this in red. Plus 180. We get 111.80. 111.80. Box our final answer. There it is. And finally, one final example. On the back, as soon as we're ready to move on. Are we good? Go ahead and do example 3 on your own. I'm going to silently do it on the board right now so you can check your work. So please do this on your own. I thought I did the same problem for a second.